Manchester encoding and differential Manchester encoding are two techniques used for encoding binary data into electrical signals in communication systems. Both methods are commonly used in Ethernet networks and other digital communication systems. Here's an overview of each encoding technique. 1. Manchester encoding. Manchester encoding is a type of binary phase shift keying (BPSK) modulation technique. 1. In Manchester encoding, each bit is represented by a transition or change in the signal level in the middle of a bit period. 1. The transition occurs at the midpoint of the bit, allowing for reliable clock synchronization and easy detection of bit boundaries. In Manchester encoding, 1. A logical 0 is represented by a transition from high to low voltage level, low to high transition. 2. A logical 1 is represented by a transition from low to high voltage level, high to low transition. The main advantage of Manchester encoding is its self-clocking nature. The transitions in the middle of each bit period provide synchronization information, which helps receivers recover the clock signal and accurately decode the data. However, Manchester encoding requires twice the bandwidth compared to other encoding schemes due to its frequent transitions. 1. Differential Manchester encoding. Differential Manchester encoding is a variant of Manchester encoding that adds additional transition information for clock synchronization. 1. In differential Manchester encoding, a transition occurs at the start of each bit period, unlike traditional Manchester encoding where the transition is in the middle. In differential Manchester encoding, 1. A logical 0 is represented by a transition if the previous bit was the same. No transition if the previous bit was different. 2. A logical 1 is represented by a transition if the previous bit was different. No transition if the previous bit was the same. Differential Manchester encoding guarantees a transition at the beginning of each bit period, even when the data is the same as the previous bit. This helps receivers maintain clock synchronization by detecting these transitions. The advantage of differential Manchester encoding is its ability to transmit data reliably without relying on a separate clock signal. However, it requires additional logic to differentiate between the transitions and decode the data accurately. Both Manchester encoding and differential Manchester encoding are widely used in Ethernet networks, especially in older Ethernet standards like 10BASE-T. These encoding techniques provide reliable data transmission, clock synchronization, and robust error detection in digital communication systems.